Hey everybody, let's start Unit 4 together. We are talking about parametric functions, which is pretty exciting. They're pretty fun. They're new, but I think you'll get it. This is pretty quick and easy. So let's talk about, for most of algebra up until this point, you've become accustomed to equations with one dependent variable, usually the y variable, and one independent variable, usually the x variable. These are called rectangular equations because they have x comma y. That given x, you find y. So just like this, we know that this is a linear equation. When I give you this x variable, I can plug it in and we get an output of y. So our independent is x and our dependent is y. Same thing here. This is a quadratic where our independent is x. You plug it in to get your dependent y value. Okay, and of course we know these are trig functions that we've been talking about, where you put an independent variable theta or x, or your angle, and you get out a dependent variable y. So let's talk about new function. We call these that have two variables that are dependent, okay? And one independent variable, we call this t, or time. These are parametric functions. So let's talk about a little bit more what parametric functions are. These are functions that have an equation for both the x coordinate and the separate y coordinate. So we say the function in terms of time, where time is your independent variable, is going to equal two parts, okay? The first part is the x function in terms of t, and the second will be the y function in terms of t, where we call t the parameter. And we describe it with parametric function. So anytime you have t, the independent, we know the coordinate f of t by substituting values into each equation, x of t and y of t. So let's see what that looks like as we apply it. So for part number one, it says, hey, at time of -1 second, meaning a second before the starting value, we have the parametric function. Hey, what's the function of time where t is independent? This is our x of t, and this is our y of t part, okay? So if I want to find where is the parametric function, remember we're going to have a value of its location, so x comma y. So we know in order to find when t is -1, we're going to find x of t. So to find x of t, we're going to find x of -1, which we see here is 6 minus t squared, right? Because x of t equals 6 minus t squared. So if I plug this in at -1 for t, this becomes 6 minus -1 squared is just 1. 6 minus 1 is 5. So when t is -1, x of -1 is 5. Let's talk about y. So in order to find y of t, which we know is t plus 3, well, I know y when t is -1 would be t at -1 plus 3. Well, this is 2. So we know y at t equals -1 is 2. So what do we say? When t equals -1, the position of f of t equals 5, 2, x comma y. So that's your 5, 2. Okay, so the parametric function tells us where the graph is at a specific time. Okay, so let's look at these. So it says create a numerical table for the function f of t equals 3t, t squared minus 1. On your copy, it might be a little dark. I apologize. So just remember, for this copy, this is x and this is y. Remember that x in this case is 3t, right? F of, or I should say x of t equals 3t, and y of t equals t squared minus 1. Let me see that here. So let's go ahead and plug this in. So I know when t is -2, X of negative 2 is going to be 3 times negative 2, which we know is negative 6. And y of negative 2 is going to look like negative 2 squared minus 1, which is positive 4 minus 1, which is 3. Keep in mind that we're going to be graphing this later, so if there are fractions, it's going to be helpful to put them as a decimal. Plug this one in here. X of t is going to be 3 of negative 3 over 2. Multiply those, we get negative 9 over 2. And we know negative 9 over 2 as a decimal is negative 4.5. Again, a decimal is going to be easier to graph later on. This one here, t squared minus 1, so I know t is negative 3 over 2 squared minus 1. You're going to need to be good at fractions if you're not already. We know negative 3 squared is 9, 2 squared is 4, minus 1. Minus 1 is like saying 4 over 4. So this gives me 5 over 4, which as a decimal is 1.25. Again, decimals are best. Plugging this one in here. When x is negative 1, I know x of t is, when x is negative 1, so we're going to take 3 times negative 1, which is negative 3. And the last one here, negative 1 squared for y minus 1 is going to be just 0. Okay, I'm going to push pause here. I want you guys to plug in the graph, or plug in these values for t and see what you get for x of t and y of t for each of these. Go ahead and unpause it when you are done. This is really important, when you're done. All right, let's go ahead and see what you guys got. I got negative 3 over 2 for this one. That's negative 1.5. This is negative 3/4, which is negative 0.75. At 0, it's 0, negative 1. At 1/2, it's 3 over 2, which is 1.5. And negative 3/4, which is negative 0.75. At 1, it's 3 and 0. At 3/2, it's 9 over 2, which is 4/5, or 4.5. And 5/4, which is 1.25. And then last, when t is 2, x is 6, and y is 3. Okay, so for our next part, we're going to actually graph this parametric function, where we remember f of t was broken up into the parts of x of t, comma, y of t. We plugged in those values, specific values, and now we're going to use the graph to plot these points. So keep in mind, our first point, we're always going to go from the lowest value of t to the highest value of t. So we're going to start at this value of t here, which was at 6 comma negative 3. So when x is, when the time is negative 2, the point is right here, negative 6. So we're going to go negative 1, 2, 3, 4, 5. Actually, negative 6 is going to be off the graph, which is fine because we can adapt. We're going to go up 6. So this is my first point. After that, we're going to go in order. This is really important. So from there, I know when t equals negative 3 over 2, it's going to be negative 4.5. So we're going to go negative 1, 2, 3, 4 and a half. And then we're going to go up 1 1/4. This next one is when t is negative 1, it's at negative 3, 0. The next one is at when x is negative 1/2. We've got negative 1 1/2 up, or sorry, down 1/4. Okay, it's blue. When t is 0, we're at the point 0 comma negative 1. When t is 1/2, we're at 1 1/2 comma negative 3/4. When t is 0, we're at 3 comma 0. Okay. When t is 3/2, we are at 4 1/2 up 1 1/2. And then the last one, we've got when t is 2, we're at 6. So here's 6 up 3. Okay. So what we're going to do is we plotted them in order, and now we're going to connect those coordinates. So remember, we started here when t was negative 2, and we went in this direction from left to right as t increases. So now I'm going to connect those dots and show the shape of the graph. We can kind of see this looks like a parabolic shape. We also know that we're going to use arrows to indicate the direction. So remember, we started from left to right, so we're showing kind of just below or showing little arrows to show, hey, this is direction that we're going, forwards or backwards. The last thing I want you to see here, and this is on your next page written out, but I want you to see this, that when we're looking at this, at the graph f of t, there was no restriction specifically on what t could be. So if there's no restriction, t could be from negative infinity to positive infinity, okay? So when it can be from negative infinity to positive infinity, this means this graph is going to continue on both ends. So when that's true, I'm going to kind of, just like we would like an actual parabola, we know that those ends continue forever left and right. This now is not always the case if there's a restriction on t. So let's look at the next one. So let's talk about when we have a restricted domain. Okay, so for a restricted domain, which means we usually have a restriction on time, you're going to have a starting point and an ending point for motion along the path that's given by the parametric equation. So we're going to use the table of values to sketch the curve. So this one here, hey, like I said, the parametric equation f of t, where this part here is x of t, and this little part here is y of t for, now this is our restriction. This tells me that t has to start at -2 and it ends at 3. We don't have more time outside of that. So here's our beginning and here's our end values of t. This chart's already filled in for us. We plugged in when t is negative, or when t is -2, we plugged it into x of t. -2 squared minus 4 is 0, and that's where we got that value from. And then we did, when t is -2, we plugged it into here, 3t over 2, and we got -3. So all of this graph is plugged in. Let's go ahead and sketch those values, okay? So when t is -2, we're at the point 0, -3, x comma y. Going from there, increasing when t is -1, we're at the point -3, -1.5. Here's our second point. At t equals 0, we're at -4, comma 0. At t equals 1, we get -3 up 1.5. Next is 0, comma 3, and then 5, comma 4.5. So we started here. We're going to connect those points. We're going to show the arrows of the direction we're going in, right? Because just by the graph, we don't know the direction of how things went over time. And we also know, because there is a restriction on what t can be, the beginning of the graph is at the point 0, comma -3 right here. And the ending of the graph is at the point 5, comma 4.5 here. And we notice because t cannot go further than that, we will have distinct ending points. So starting and ending points, these do not go on forever. All right, that's all we have for today. I'll see you back in class.